Okay, let's get with it. All right, welcome, ladies and gentlemen. So now let's get on to our trigonometry review. So what we're going to do is, again, work through some free response questions, and then we'll get into the multiple choice. So the first question that we have is just to evaluate the 6 trigonometric functions. And you can see here we have a trigonometric equation, we have a trigonometric equation and a constraint, and then we have a coordinate point. So the nice thing is when we just have a trigonometric equation without any context to it, then it's just going to be a triangle in space. So we can just draw a nice little triangle. And we can put our alpha wherever we want to. I'll put it right here. And then that would be 2, and that would be 5. Now, you could use Pythagorean theorem, but hopefully you got to kind of get a little used to this. And if you did 5 squared or 2 squared plus x squared equals 5 squared, that'd be 25 minus 4. That should be the square root of 21. Okay? So therefore, if cosine of alpha is going to be 2 over 5, we can figure out the secant of alpha. That's just going to be the reciprocal, right? So that one's kind of easy. 5 halves. Oh, come on. It's so annoying. All right, we can do the sine of alpha. That is going to be opposite over hypotenuse. And then we can do the tangent of alpha. That's going to be opposite over adjacent. So that'd be square root of 21 over 5. So we already have cosine, so I'm not going to list that again. For the sine, that's just going to be a reciprocal. For the reciprocal, that'd be cosecant. All right, you got to be serious. Cosecant of alpha. Well, I have this at least recorded, so I can upload this from on there. So cosecant of alpha is going to be hypotenuse over opposite. So that'd be 5 over square root of 21, and you can rationalize the denominator, so that'd be 5 square root of 21 over 21, and then we could say cotangent of alpha, and that's going to be 5 over the square root of 21. Rationalize the denominator, that'd be 5 square root of 21 over 21. Okay, now in the next example, we have tangent of beta equals negative 3/4. Now again, tangent is only going to be negative in the second and the fourth quadrant. But since sine of beta is less than 0, then this is going to be our triangle. So we're going to use this as our triangle. Okay, so we can put beta anywhere. So I'll put a beta here. And therefore, tangent is opposite over adjacent. Well, that can't be a negative 3, right? That's going to be a negative 4, right? Because it doesn't make sense for 3 to be a negative over here. Hopefully you recognize this is a Pythagorean triple. So this answer right there is going to be 5. All right, so if we have tangent of beta, then we know the cotangent of beta is just going to be reciprocal, 4/3. We could do the sine of beta. That is going to be opposite over hypotenuse, so that's going to be a negative 4/5. We have the cosine of beta, which is going to be adjacent over hypotenuse. Man, my penmanship is going down the tubes. Sine of beta is going to be, reciprocal functions. So cosecant of beta is going to be 5 over negative 4, so that'd be negative 5/4. And the secant of beta is going to be hypotenuse over adjacent, so that's going to be 5/3. And then for the last one is a coordinate point. So in this one, you're just going to want to sketch the graph. So here we'll have a negative 2, and then 6. 1, 2, 3, 4, 5, 6. So go ahead and plot the point, create that right triangle. Again, you can use your angle. You can use any angle you want to, but you're going to have to pick something. In this case, I'll just use x. And then we know that this is negative 2. This is going to be 6. If you use the Pythagorean theorem, that's going to be 36 plus 4 is going to be a square root of 40, which can be simplified into a 2 square root of 10. So let's go through all of them. So I have sine of x is equal to 6 over 2 square root of 10. That can be simplified to 3 over square root of 10, which is equal to I'm going to zoom in. I'm having trouble with this. So that's going to be a 3 over a square root of 10. And then that can be simplified, rationalized. The denominator would be a 3 square root of 10 over 10. For the cosine of x, that's going to be adjacent over hypotenuse. So that'd be a negative 2 over a 2 square root of 10, which is a negative 1 over square root of 10, which is equal to a square root of 10 over 10. And then we have the tangent of x, which is opposite over adjacent. So that's going to be a 6 over negative 2, which equals a negative 3. All right, so now let's go into the reciprocal functions. I'm a little bit low on space, so I'll just kind of put them here. So cosecant, so cosecant of x, that is going to be hypotenuse over opposite. So that's going to be 2 square root of 10 over 6, which is going to equal, you know, I don't have enough space, so let's do these on the bottom. So that's going to be a square root of 10 over 3. For the secant of x, that's going to be a 2 square root of 10 over negative 2, which equals a negative square root of 10. And then cotangent, I can do that one. That one's not too bad. Cotangent of x, that one's going to equal a negative 2 over 3. Sorry, negative 2 over 6, which is equal to a negative 1/3. Okay, so there you go. Just to make sure you remember when you have these triangles, create the triangles. You can see in all these problems I had to create my own triangles and then just use your trig, your SOHCAHTOA to identify those parts. All right, the next one says label the characteristics that apply. So amplitude, period, so anything that they have, we're just going to label all that stuff. Okay. So remember sine, that does have a amplitude. So the amplitude here is going to be the absolute value of 2/3, which is just 2/3. Main thing we want to do though is make sure we factor out that 2, that b. Actually, we got to rearrange this first. So I'm going to rearrange this to a negative 2x plus 2 pi. And then you can factor that even further by factoring a negative 2, and that would give you x plus pi. Okay. So that is going to be your inside term. And that's very important for you to make sure you rearrange. Make sure you have the x first, and then make sure you factor out anything that's in front. So my period is going to be 2 pi divided by b, absolute value b, which is just 2. So that's going to equal a pi. We have the phase shift. So phase shift is going to be, let's see, left pi. Vertical translation, none. We have a reflection, so we're going to reflect the y-axis. Okay. There is no asymptotes. The domain is all real numbers. And the range is going to be basically how low and high the graph goes. Since the only thing that vertically has happened to the graph is being it's vertically compressed by 2/3, we can say that's going to be from negative 2/3 to positive 2/3. Okay. And yeah, so there you go. The next one is the secant graph. All right. So again, this one doesn't have an amplitude, but we can see that the period is going to be 2 pi divided by 2/3, multiplied by the reciprocal. That's going to equal a 6 divided by 2, so that'd be a 3 pi. We do have a vertical translation, which is going to be up 1. We are vertically stretching the graph, but that's not going to, that would impact our range here, but that's not going to impact our, there's no amplitude here. We do have a reflection now about the x-axis, so you can say reflect x-axis, and we do have some asymptotes as well. So that's something we'll talk about here as well. So let's talk about the range, because I think that's easier. Actually, let's go through the range. Okay, so the graph has been shifted or stretched from -2 to +2, but then got shifted up 1. So the range is going to go down to -1 and then up to 3, right? Because that vertical stretch takes you from -2 to 2, and then the graph gets shifted up 1. The asymptote equation for secant, so we got to think that's the reciprocal of cosine. So you got to think, when is cosine equal to 0, right? Because that's going to be where the vertical asymptotes. So cosine is equal to 0 at pi halves and 3 pi halves. So all you're simply going to do for the vertical asymptotes is you're going to take whatever's inside your function, so in this case 2/3 x, and set that equal to pi halves plus pi n. That is the asymptote equation based on our notes. Then you can just solve for x. So x is going to equal 3 pi. So if you now multiply by 3 halves times everything, right? And what you'll basically get is going to be if you multiply across, that's going to be 3 pi over 4 plus 3 pi halves n. Oh, that's a horrible 2. So there you go. That is going to be your vertical asymptote. And the domain is just going to be all real numbers except for that value. So it's going to be all values of x such that x cannot equal, 3 pi over 4 plus 3 pi halves n. All right, so now let's get into the cotangent. So remember, cotangent is very similar to the tangent function. The period is just going to be pi divided by b. So in this case, it's pi divided by 2, which is just going to be pi halves. We don't have a vertical shift. We don't have a phase shift. We just have a vertical stretch. That's fine. The range is going to be all real numbers. So that's going to be from negative infinity to infinity. We do want to know the asymptotes, though, to identify our domain. So we want to think about when is y going to be 0. So the cotangent function, if you recall, that is going to be when x is over y, right? So that's going to be undefined every pi n. So for my vertical asymptotes here, I'm going to take whatever's inside my function and set that equal to pi n. So x in this case equals every 2 pi n. So my domain is going to be x such that x cannot equal 2 pi n. And there's nothing else going on with that one. I mean, it's being vertically stretched, but that's not one of our characteristics. So just want to make sure you know all the characteristics as well as how to apply them to the functions, and make sure you know the asymptotes and the domain and range for those graphs. All right, now let's get into evaluating the unit circle. There's a couple points that I tell my students that you basically need to know for this. At this point, they should be able to do it in their head. But we all know that that is not going to be the case, right? So let's go ahead and draw the first quadrant. Therefore, students can reference my work as they need to when we're going through this. Okay, but basically these problems should be done rather quickly as possible. So this point is going to be 0, 1. This point is going to be 1/2. Come on. Comma, square root of 3 over 2. This is square root of 2 over 2. I'm going to zoom in one more time. 2. Here is square root of 3 over 2, comma, 1/2. And then this point is 1, 0. Okay. And then the only other point that I want students to basically know also is these points that I was talking about for these graphs. Right? You should know these points here. This is 1, 0. This is 0, 1, negative 1, 0, and 0, negative 1. Just put parentheses around these. Okay. And then I forgot to kind of mention what these angles are. So this angle, remember, is pi over 6, pi over 4. Come on. This is going to be pi over 3, and this angle is pi halves. Okay, so now let's go and get into our graphs. I'll zoom out so we can see both of these. All right, so sine of 3 pi, remember sine is going to be the y coordinate, so I'm just going to graph 3 pi over 2. That's going to be right there. So the y coordinate here is negative 1. All right, cosine of negative 7 pi over 6, that's going to be right there. That has a reference angle of pi over 6. So therefore, it's going to be the cosine, which is going to be square root of 3 over 2. However, it's in the second quadrant, so it's a negative square root of 3 over 2. 7 pi over 6, that's the exact same angle, but now it's the positive angle, okay? Again, that is going to be the y coordinate, so that's going to be tangent is positive in the third quadrant. That's going to be y over x, and if you think about that, you have 1/2 divided by square root of 3 over 2. Hopefully, you've done enough of these problems that you know that that answer is going to be square root of 3 over 3. The secant of pi over 4, that's going to be 1 over square root of 2 over 2. And if you've done enough of these problems, you recognize that point is going to be multiplied by the reciprocal. Actually, that should be the square root of 2. So that's pi over 4. So yeah, when you multiply by 2, rationalize the denominator, you're going to get a square root of 2. All right, cosecant of negative 2 pi. So negative 2 pi. Let's see, negative 2 pi here, that's going to be all the way around the circle. That's going to be 1 over y. which is 1 over 0, which you can see here is going to be undefined. All right, cotangent of negative 3 pi over 4. So negative 3 pi over 4, that's going to be right there. On the unit circle, that's going to be 1 over, that's going to be the x over the y. But again, that's in the third quadrant, so it's going to be positive. So that's equal to a positive 1. Cosine inverse of negative 1/2. So notice now we're not looking for the value on the unit circle, we're looking for the angle. So cosine inverse of negative 1/2. So you can recognize that cosine is equal to negative 1/2. There's going to be two angles where it's equal to negative 1/2. That's going to be up there. It's going to be up here and over here. But remember, the restriction for cosine inverse has to be between 0 and pi. So it's only going to be that angle, which is 2 pi over 3. Tangent inverse of square root of 3. So again, we kind of talked about this one. Is we know that in 1/2 over square root of 3 over 2 is square root of 3 over 3. So if we're looking for, remember, tangent is x over y, right? So we're looking for the tangent of what angle gives me an x over y. That simplifies that. Well, that's going to be a square root of 3 over 2 over 1/2. Okay, and so I can look at that. That's going to be the y over the x. And looks like to me that's going to equal pi over 3. Okay, and remember the restrictions here for pi over 3, or tangent, sorry. The restrictions for tangent inverse is going to be between pi halves and negative pi halves. And again, we're looking for the square root of 3 over 2 divided by 1/2. And this one, 1,000 pi over 6, so yeah, that'd be pi over 3. There you go. All right, so now we have now we're just going to do a composition. So remember, when we're doing composition, basically we're going to work from the inside out, okay? So we're going to evaluate the cosine of 3 pi over 4 first, and then we're going to do the sine inverse. So the cosine of 3 pi over 4, let's see, that's going to be the sine inverse of 3 pi over 4, so that's going to be negative square root of 2 over 2. And then the sine inverse, well, that's going to be negative. So there's only two values where sine is equal to negative. But again, the restriction for sine inverse is the first and the second quadrant, like tangent. So that has to equal a negative pi over 4, okay? Because you have to go down. You can't go outside of that restriction. Now let's go and do tangent and cosecant. So cosecant of pi halves. Cosecant of pi halves. So cosecant of pi halves is right there. So that's 1 over y, so that's going to be 1. So then we have the tangent inverse of 1. And tangent is going to be equal to 1 at pi over 4. So that would equal to pi over 4. And again, that's going to be positive, so again, that will be in the first quadrant. Now in this next example, we do not have the hypotenuse over the opposite is not going to create a triangle on the unit circle, right? If you were to draw a triangle here, and let's draw this triangle. If I said the secant, which is the adjacent, that's the hypotenuse, over the adjacent side, right? Well, that doesn't have a hypotenuse of 1. This is not on the unit circle. However, if we do have two sides of a triangle, we can identify our third side to be 12, right? So really what it's saying, if the secant inverse of 13 over 5, that's going to produce some angle, whatever theta. And basically all we're trying to do now is say, all right, if that is going to give us theta, then what's the cotangent of that? What is the x over the y? Well, that's just going to give us a 5/12. And you can do kind of the same thing here when you have the tangent of sine inverse of x. So again, remember, all trigonometric functions also can be rewritten as a ratio. So if you draw this as a trigonometric ratio, and you say, all right, that's opposite over hypotenuse. So again, we don't know what x is. X can be some fraction, right? Now, if we were to use the Pythagorean theorem to figure out this adjacent side, because we need to figure out tangent, which is opposite over adjacent. So let's call this value c, okay? So let's go and see if we can figure out what c is in terms of x. So we could say c squared plus x squared equals 1 squared. Now, if we're going to solve for c, we could say c squared equals 1 minus x squared, and then you could take the square root, and you could say c equals the square root of 1 minus x squared. So if I wanted to rewrite this just in terms of x's, I could say c is the same thing as 1 minus x squared. Okay? So now, basically, we just want to figure out, well, what is the tangent of this? So here's your angle. Let's make this angle but I shouldn't have used x. Well, yeah, let's just call this theta or something. So now what is the tangent of this angle, of this triangle, based on theta here? Because if that's the sine would be x over 1, then that would be the tangent. And then you just say, okay, well, that's going to be equal to x over the square root of 1 minus x squared, which could also be simplified to x square root of 1 minus x squared all over 1 minus x squared, if you rationalize the denominator. All right, so there we go for the free response. Now what I'm going to do is go through the multiple choice. And I'll just kind of do these a little bit quicker, or at least as quick as I can, show a little bit of work, but then go, not go through as much explanation. Just try to find the answers as quickly as I can. All right, so solve for y. And now again, we're not gonna have a calculator here. So 60 degrees. So I remember that a couple different ways we could understand this is 60 degrees. This is going to be the short leg. If you can remember, go from short leg to long leg, you're just going to multiply by the square root of 3. That is your special right triangle relationship. So that would be answer A. You could also think about this in terms of your unit circle, and you wouldn't want to use 2 here, but you'd have to go and understand the relationship of 60 degrees for 1, and then just multiply that by 2. So kind of a little bit weird thing, but I think knowing your special right triangles would be the best use there. The next one says find the exact value of the cosecant of theta. So A is 24, so let's just write that as 24, and B is 7. All right, so the cosecant is going to be opposite over hypotenuse. So we need to figure out what that is. Looks like this is Pythagorean triple, so I'm going to say that's going to be 25. So therefore, that'd be hypotenuse over opposite of your angle theta. So that's going to be A. Determine a pair of coterminal angles in radian measure of pi half. So we're just going to be adding 2 pi. So again, 2 pi is equal to 4 pi halves, right? So if you add 4 pi or subtract 4 pi, that doesn't work. That one doesn't work. No, 5 pi would work. If you subtract 4 pi, so 3 pi over 2, though, it doesn't work. If we added 4 pi here, that would give us 5 pi. We're not going to get that. We will get a negative 3 pi over 2, though. Okay, so that one looks good. And that one would not work. So D is our answer. Next one says convert the degree measurement to radians. So hopefully I didn't make a mistake. I don't know why it's highlighted. So add into your expression multiples of pi. Okay, so remember to go from degrees to radian mode, you're just going to multiply by pi over 180. So I have 480 divided by 180, which I basically need to go ahead and convert. 18 goes into there. I guess I have, let's see, I can divide by 2, or it looks like you can divide by a 6. Yeah, 6 would go. So that'd be a 3, and that'd be 6 times 8 is 48. So 8/3 pi. There you go, C. Convert to degrees. All right, so then in this case, we're going to multiply by 180 degrees over pi. Those divide out, so you're going to left with a negative. 4 goes into there 45 times. Definitely doesn't need a pi. So we'll go from there. The 0.85 is coterminal, or is on the terminal side of standard. Find the exact value of sine. So let's go ahead and sketch this here. So we have 8, 5. Looks like the 64 plus 25, so that's going to be square root of 89. So it looks like the only answer here is going to be B, right? We're looking for sine. So that looks good. Find the indicated trigonometric value in the specific quadrant. All right, so, we do need to figure it. So it's in the 4th quadrant. All right, so what do we know about the 4th quadrant? So in the 4th quadrant, we know that's positive and, I'm sorry, that's negative. So we know this is going to be negative and that's positive. All right, so they're giving us the cosecant, which is hypotenuse, which is always positive, over -2. All right, so then I'm assuming everything else is 3 squared root of 3. So I'm assuming I don't even, I could use my math, but I could just say, well, all right, let's just go with that, right? It's not going to be 2 over 11. Actually, is it? No, it's secant. They're asking for secant. So that's going to be hypotenuse over that, which has to be positive. And the only answer that would work there would be C, which makes sense. Find the exact value. of the indicated trigonometric function. So again, another one of these. We're looking for tangent. All right, so sine is less than 0. Secant is positive. So again, this is in the fourth quadrant again. That's not supposed to happen. All right, so let's draw a triangle in the fourth quadrant, just so we make sure we have this correct. So that is going to be hypotenuse over adjacent. Sine is less than 0, so that's going to be negative. And they want us to find tangent, so that is going to be something over 2. Dang it. Well, it's not going to be 9, right? 9 is the hypotenuse. Tangent has to be this over 2, so I'll just go with 77. And that makes sense. I mean, 81 minus 4 would be, yeah, 77. So that works. All right, determine a quadrant in which negative 182.2 degrees lies. Well, let's just think about this. So negative, so that's negative 90, that's negative 180, that's negative 270. So it's going to be past that, so be quadrant 1. All right, evaluate the trigonometric function as a period of its aid. So what they mean from there is we can rewrite 13 pi over 2 equal to 4 pi over 2 plus 4 pi over 2 plus 4 pi over 2 plus pi over 2, right? That's a revolution. Oops, let's do it this way. That's a revolution, that's a revolution, that's a revolution. So 4, 8, 12, right? So 3 revolutions, and then you have an extra pi halves. So really, we're just trying to evaluate the sine of pi halves, which I'm not seeing the answer on. Oh, I'm an idiot. That's over 3, not over 2. Ah, dang it. All right, so that was the right idea, but the wrong numbers. Let's go and fix that. All right, so that's going to equal over 3. So that's going to be 6 pi over 3 plus 6 pi over 3. So that's going to give me 12 plus pi over 3, right? Because 6 plus 1 is 13, keeping the same denominator. But 6 pi over 3 is just a revolution. That's a revolution. So we have sine of pi over 3. So you think pi over 3, that's the y coordinate. That's in the first quadrant. That'd be A. What is the secant of 5 pi over 3? Let's go and 5 that angle. So 5 pi over 3 is going to be right there. So cosine is going to be positive. So it's not that one and not that one. Reference angle is going to be pi over 3, which is going to be 1/2. Right? So if I'm looking at pi over 3, yeah, pi over 3. So that's going to be 1 over 1/2, which would be D. Secant, yes. So 5 over 3. Good. The next one is evaluate 7 pi over 6. So let's go here, 7 pi over 6. Reference angle is going to be pi over 6. So theta prime equals pi over 6. So if you think about pi over 6, that's going to be 1/2 divided by square root of 3 over 2. That's going to be square root of 3 over 3. That is in the fourth quadrant, which again is positive. All right. Oh, I think I was going to change maybe one of those. I don't know. See if I need to change. Whatever. Determine the phase shift. So the phase shift is how you're moving left or right. So again, to do that, you're going to need to factor out of 4. So by factoring out of 4, that's like dividing out of 4. So that's going to be negative pi over 8. So it's going to be 8 to the right because it's positive. Write the equation for the given the function given the period, phase shift, and vertical shift. Use the tangent function. All right, so pi needs to be divided by 7 to give us the phase shift, so it's not going to be those two. Vertical shift is at 4. Phase shift is 1 pi halves to the third. These are exactly the same, but I'm not sure how would you differentiate between those two, because both of those, if you divide by 7, you could factor out a 7, and in that case you'd get theta minus 1/3. All right, so I need to fix this. Let's say phase shift right. Oh, well, it's going to be a positive 1/3. Okay, so that's going to be to the right, right? So that'd be the phase shift positive 1/3. So it's going to be, so that's correct. That's not the way that I teach, but a lot of books do talk about if the phase shift is positive, that means you're shifting it to the right. If you're doing a phase shift negative, that would be going to the left. So if we're going to the right, then which transformation is going to take us to the right? That'd be A. I just don't teach it that way. To me, it kind of gets confusing. Find the amplitude. Amplitude's absolute value of A, so that's 5. Those are nice. Determine the asymptotes. Crap. So the asymptotes of cosecant. So let's think about, that's when sine's equal to 0, right? So when is the y curve? Okay, so that's going to be, so it's going to be 4x plus pi is equal to pi n, right? Because sine is equal to 0 at 0 and pi. So let's see, we can subtract the pi. Okay, so 4x equals negative pi plus pi n. Well, that's not really changing anything, right? I mean, if you just subtract pi, but you're always adding pi n, so we can just rewrite that as 4x equals pi n, and then divide by 4. So x equals pi over 4 n. C. Determine the period. So cotangent, remember, is pi divided by 1/4. So multiply by the reciprocal, that's going to be A. 18 is going to be evaluate. So again, we need to make sure that we understand when we're trying to evaluate cosine inverse, we're looking for the angle. Again, this is cosine of what angle equals a negative square root of 3 over 2. Well, there's only 2 angles that works. That is going to be here and here. But the restriction of cosine is within the first and the second quadrant, which means it's going to be this angle, which has to remain. They can't do the negative angle. It has to be the positive angle. So that's going to be a 5 pi over 6. Number 19 says, find the algebraic expression equivalent to arc secant of u. So again, remember that's going to be, let's draw our triangle here. So remember secant is going to be hypotenuse over adjacent. So that'd be over 1, right? So now we basically need to figure out what this side length is, and let's call it x. So we can say 1 squared plus x squared equals u squared. Solve for x. So again, that's going to be x equals the square root of u squared minus 1. All right, so then they're trying to find the sine. So the sine is going to be square root of u squared minus 1. That looks horrible. All over u. It looks like that's answer C. And then last but not least is going to be number 20. And I love this type of question because you're like, oh, it's on the unit circle. Okay, I got this. And then you're like, oh, crap, it's not on the unit circle. But that's okay. We don't actually need it to be on the unit circle because we can just use our reference angles. So I have the tangent of 6 pi over 7. And you're like, crap, what is the tangent of 6 pi over 7? Well, to understand this question, we have to graph where would 6 pi over 7 be? 6 pi over 7 is going to be right here, right? Okay, so the cool thing about this is all I know about this angle, I don't really know much about this angle, but I know that it's going to give me a negative value, right? So I'm going to have a negative x coordinate and a positive y coordinate, okay? So it's going to give me some negative value. Now, the interesting thing, and I think the best way to understand this is actually to go by to like something we do know. Let's do like 5 pi over 6. That's something very similar, right? So what if I change this problem to tangent inverse of tangent of 5 pi over 6? And sometimes when you're trying to understand these problems, it just makes sense to like do numbers that you do know. So tangent of 5 pi over 6, that's going to be, that is, let's see, negative square root of 3 over 2 comma 1/2. Okay, so that's going to be tangent inverse of a negative, let's see, y over x, that'd be a negative square root of 3 over 3. And then you say, well, what angle works for that? Well, remember, tangent inverse is going to be within the first and second quadrant. So it can't be that angle. You can't just say it's going to be 5 pi over 6 because that doesn't fall within the restrictions. So if you look at it, it's going to have to fall down here. So therefore, the angle here to satisfy this would be theta equals a negative pi over 6. So basically all you need to do is find the reference angle here and then do the negative version because that's what the answer is going to be. So we say, all right, well, then what's the reference angle of 6 pi over 7? Well, that's going to be pi over 7. But again, it has to be the negative version because it has to satisfy the restriction here. So it'd be A. So there you go, ladies and gentlemen. Those are always long reviews, but I'm glad I went ahead and got that for you. So that is all you need for your semester review. Hopefully that was a good review for you. Again, if you have any questions, let me know. But otherwise, best of luck on your test. See you guys soon. Cheers. All right. So let me go and check to make sure if there's anything else that you have for me. Oh, thanks.